Hi, in this video, I'm going to be looking at solving systems that are not linear, but at the beginning, I just want to do a couple more 3x3 systems. So this is a 3x3 system. We've got three equations that are linear, and we're being asked to solve this. So for this one, what we're looking for is an ordered triple that has an x, a y, and a z that's going to satisfy all three equations. All right, so it really pays to kind of look at things a little bit. I'm looking for what variable to try to cancel out initially. And I'm seeing how x has an understood 1 in front of it, and also how the z here has an understood 1. This one has an understood -1. All right, I think if I were choosing, I would get rid of either the x or the z. And I feel like if I get rid of the z, equation 1 and 2 are kind of already set up so that I don't even have to tweak either equation in order to get those to cancel out. Okay, so remember, our plan is to try to take two of these equations, if necessary, adjust them a little bit so that when we add them, we wind up getting one of the variables to cancel out. Then take a different two equations and do the same thing. Get the same variable to cancel out. So I'm going to go ahead and take equation 1 and equation 2, and I'm just going to add those two equations together. I didn't have to tweak anything because I had a 1z and a -1z. So adding them like this, that's going to cancel. So I have 4x plus 6y equaling 28, okay? Now, that is the equation that we've been labeling equation 4. And we're trying to create an equation 5 over here that has the same variables as equation 4. That's going to be critical. And so with this one, I took equation 1 and 2 as is and was able to add them. What I'm going to do now is go back up, and I'm going to take a different two equations and get rid of z again. So I might take maybe equation 1 together with equation 3. Okay, so look at how equation 3 has a 2 in front of the z. So if I could turn this coefficient on the first equation into a -2, then when I add those, the z's would cancel. Okay, so I could do that if I multiplied that first equation by 2. So I'm going to do that. I'm going to multiply through by 2, and I get 2x on that first equation plus 8y minus 2z equals 40. I'm going to bring the second equation along. The third equation is what I meant. Along. Okay. And I set it up so that the z would cancel out. So now I'm going to add, and I get 4x, add the 8y minus 3y, I get positive 5y, and I'm going to add the 40 and the -16, and I get 24. Okay. All right, so now I've created my equation 4 and 5. What was important is that they had the same variables. So once I decided I was going to do this to get equation 4, equation 5 has to have an x and a y in it. All right, so now we're ready for the next stage. We're going to take equation 4. We're going to take equation 5 and look at the two of those. Okay, so this is my equation 4 and my equation 5. All right, now these don't really have to be tweaked very much. If the x's are almost ready to cancel out, all I need to do is get a negative right here, and I could do that by multiplying all the way through by -1. All right, when I do that, the x's are gone. 6y minus 5y is 1y. 28 minus 24 is 4. And I wind up getting my y value. Okay. Now, you're going to now need to go and try to work on getting the x and the z. But what we'll do is we'll backtrack. Can't go all the way back to the original 3 equations. We'll backtrack to either equation 4 or 5. Okay, so let's say we take equation 5. It's sitting right there. We will go to one of these two because you only have 2 unknowns, and we know that y is going to be 4. So we're going to put a 4 right there. And then we only have x left. And so we have an equation that we can solve for x. 4x plus 20 equals 24. So you're going to take away the 20 from both sides. Okay, that gives you the 4x equaling 4. And then you're going to divide both sides by 4, and x would equal 1. So now we know the x and the y, and we need the z. So to find z, I need to go and pull an equation that has a z in it. So I'm going to take equation 2. I could have taken any one of those, but I like the way equation 2 doesn't have any negatives. Okay, 3. So I'm going to take equation 2. It could have been any one of those. And what was it? Equal to 8? Yeah. And then I'm going to plug in the y, plug in the x, and work out what z equals. So that's 3 plus 8. Okay, so that's z plus 11 equaling 8. So when I take away 11 from both sides, I wind up getting that z would equal -3. Okay. Now you don't just circle those. When you go to MyMathLab, it's going to want the point in common to all 3 lines. And so it's an x of 1, a y of 4, and a z of -3. Okay. All right, and then I wanted to do one more 3 by 3. It just doesn't look like it's a 3 by 3 because you've got 3 equations that only have 2 variables in them, but they don't have the same 2 variables. And so you really do have 3 different variables, an x, a y, and a z. Okay. All right, so it's almost like on this one that we could use one of these as an equation 4. It's like maybe we could already act like we've done something to get an equation that has 2 variables in it. Okay, so we could do that. So, we might do something like this. We might say, well, let me just use this and call it equation 4. I just didn't have to do something to eliminate a variable. Well, then that means to create equation 5, I need to do something to these 2 equations so that I get x, an equation with an x and a z in it. So see how this has an x and a z, but it also has these y's? Okay, so this is a kind of confusing because it's not typical. So people kind of get thrown a little bit when they're trying to figure out what to do. But if I want to take equations 1 and 2 and get rid of the y, so all I have left is an x and a z, I would have to multiply that first equation through by 2. So let me do that. So here would be the new first equation. It's really the same set of points. It's just got bigger numbers. Let me pull the second equation over. And really, it might be better if I had spaced that so you could really see what's going on. Let me do that. See, what's happening is that first equation is 6x minus 2y, and there's no z equal to 6. Second equation has the y plus the z equaling 14, but has no x. So you might like to, stretch it out a little bit so you can line up your like terms. Okay, so now we get here a 6x, the y's are gone, plus the z equaling 20. Okay, so that's our equation 5. So it's like half of the problem has been done for you, so you think it should be an easier problem, but because it's atypical, sometimes that throws people. All right, so now I'm going to take and start that second part of the process. So I'm going to take our equation 4 and our equation 5, and I'm going to just focus on those. Okay, so I'm looking at those and I'm thinking, okay, what can I do to try to eliminate one of the variables? Because x is by itself on the first one and z is by itself on the second, I think either variable you could have chosen to eliminate. I'm going to get rid of the z. I'm going to come down here and multiply by -24. Okay, so the equation 5 becomes -24x minus 4z equals -80. Equation 4 is x plus 4z equals 11. I didn't do anything to it. All right, now be careful about your positives and negatives. A positive 1 and a negative 24 is negative 23x. The z's are gone. A positive 11 together with a negative 80 is negative 69. I'm going to divide by negative 23, and I wind up with x equaling a positive, that would be 3. Okay, so there's one value. Now, something that's a little kind of nice about this is once we know x is 3, we have an equation with an x in it there that would allow us to get y. We have an equation with an x in it there that would allow us to get z. Okay, so we could actually use the 3 to do both of those. So if I take my equation 1 and I plug 3 in for x, I would wind up with 9 minus y equals 3. Okay, so then I would take away the 9, which means I'd have negative y left equaling a negative 6. And that negative y is really like a negative 1. So divide by the negative 1, and that would give you y equals 6. Now, I could go, if I wanted to, and plug in the 6 for y on the second equation. Or like I said, you could take that third equation and just plug x in again. And this equation has a z in it. So I could go in at this point and just take away 3. And that would give me 4z equals 8. Take away divide by the 4. And I would get z equals 2. Okay, so the answer should be a 3, a 6, and a 2. Now, I didn't do it, but these could be checked before, if it was a quiz or a test, before you hit submit. And all you would do is take like your 3, 6, 2, go back to the original, think about x of 3, y of 6, z of 2, and just think, if I put in a 3 and a 6, do I get 3? Yes. If I put in a 6 for y and a 2 for the z, do I get 12 plus 2? Do I get 14? Yes. If I put in a 3 for the x and I put in the 2 over here, I get 3 plus 8, I get 11. It checks. This is a solution to all 3 of them. Okay, and you could have done the same on the previous problem. All right, I'm going to go ahead and stop the video rather than getting into the nonlinear ones right now, so that my videos stay short, and then I'll continue with this piece of paper and just do some nonlinear ones.